Today I'm going to go over the basic derivative rules. Let's start by taking a look at the first three rules. The first is the derivative of a constant, which is always 0. For now, just think of a constant as a number on its own, not multiplied or divided by a variable like x or y. So the derivative of any number that is by itself is 0. The second rule is the power rule. The power rule says that the derivative of a variable raised to a power n becomes n times x raised to the power of n minus 1. This one will become clearer with an example, so don't worry too much about it now. The third rule is the constant multiple rule, which says that the derivative of a constant multiplied by some variable or function is just the constant multiplied by the derivative of that function. Note that this is a different situation than the first rule, because this rule applies when the constant or number is not by itself, but rather multiplied by a variable or function. Here is an example of each of those three rules that we just discussed. In the first example, the function f of x is just 3. Since there is no multiplication here, 3 is just a constant, and so its derivative is 0. In the second example, we see x raised to the power of 4, which tells us that we need to use the power rule. So we identify the different parts of the power rule and match them with the function that we have. X is the same in both, n becomes 4 in this example. Then we simply follow the rule to determine the derivative and simplify the exponent, since 4 minus 1 is just 3. In the third example, we see a constant 3 multiplied by a function x squared. Since the constant is multiplied here, we need to use the constant multiple rule. Again, we match the different parts of the rule to our function, follow the rule, and simplify. Using the constant multiple rule almost always involves using another rule as well to take the derivative of whatever is being multiplied with the constant. So in this case, we also had to use the power rule to get the derivative of the second piece before simplifying everything. Here's a chance for you to practice these three rules on your own. You can pause the video, solve these, and then check your answers in a moment. Here are the answers to those practice problems. Note that the case of x in problem 6 is a little tricky. First, you have to realize that x is the same as x to the power of 1. Then, use the power rule to get 1 times 1 to the 1 minus 1. 1 minus 1 is 0, so now we have 1 times x to the 0. And finally, we have to recognize that anything to the power of 0 is actually just 1. So for example, even 25 to the power of 0 is still 1. This may be a little challenging to think about, but the good news is that you don't run across powers of 0 very often, except when dealing with just plain x's. So the easiest thing to do is just memorize that the derivative of a single x with no exponent is just 1. Let's look at two more basic derivative rules. These look more intimidating than the first few, but I promise that they're not too bad. The fourth rule is called the sum rule, and all it says is that if we have two pieces added together, we can take the derivative of each separate piece and then add the derivatives of those pieces together. This works for subtraction too, because remember, addition and subtraction are the same type of operation. It seems pretty obvious that you could just add the two derivatives, but as you'll find out later on, derivatives with multiplication and division don't work so nicely. The second rule here is the general power rule, which says that if we have a function raised to the power n, then the derivative is n multiplied by the function raised to a power of now n minus 1, and then all of that multiplied by the derivative of the inner function. This rule looks very similar to one that you've already learned, the power rule, and in fact these two rules are related. The power rule is just a specific case of the general power rule, when the inner function is just x. If that's the case, then the derivative of x, as we discussed previously, is just 1, so the ending piece can be ignored. If you're unsure of which rule to use though, go with the general power rule because it will always give you the right answer, no matter what the inner function is. So now let's see some examples. Here's an example of the sum rule. Just like we've done before, we write out the rule, match the pieces of the rule to the function we have, and then follow the instructions of the rule to get to the derivative. Here we can see that we have two separate pieces added together. So we just take the derivative of each piece separately and then add the derivatives back together at the end and simplify. Here's an example of the general power rule. Again, we're going to write out the rule, match all the pieces, follow the rule to get to the derivative, and then simplify. Here, our inner function in this example is 3x squared plus 2, and the power it's raised to, n, is 5. So we have 5 multiplied by the inner function, then raised to a power of 5 minus 1, and then all of that multiplied by the derivative of that inner function, which we can just think of as a little mini problem within the larger problem. If we were asked to just find the derivative of 3x squared plus 2, we know we'd have to use the power rule and the derivative of a constant rule. So you can see how these rules quickly build on each other, making it easy to practice all the rules you've learned so far. Here are 4 practice problems to try yourself. The first 2 use the sum rule, and the second 2 use the general power rule. Remember that you'll likely have to use some of the previous rules as well, but you don't necessarily have to write out every step. If you know how to use a rule without writing it out and going through the steps of matching, then don't worry about those parts. And if you're not there yet, don't worry, just take it slow, and with more practice, these rules will become easier. Here are the solutions to those practice problems. Note that particularly as we get into more complicated rules, simplifying can be a bit confusing. Take a moment to check your answers, and then I'll talk a little bit more about simplifying. So particularly with the general power rule, you can often multiply the constant at the beginning with the piece at the end. However, most of the time you cannot distribute the constant over the piece in the middle because of PEMDAS. Remember that exponents are before multiplication in the order of operations, so we would have to multiply out the part that had the exponent before distributing the constant, and trust me, it is not worth the hassle. So, if you recognize that the end piece doesn't have an exponent, then the constant can be distributed over the end piece. But before simplifying, always make sure to remember the order of operations so you don't end up making a mistake right at the end. If you're unsure of whether or not you can simplify, your solution is still correct without simplifying unless the problem specifically tells you that the answer must be in its simplest form. So most of the time, if you don't know what to do next, you can just enter the answer right after using the derivative rule or rules without simplifying. I hope this video helped you learn the basic derivative rules. Thanks for watching.